Hello, welcome to Short Sir classes. So this is question from ISI M.MATH paper 2022 and the code of this paper. So this is the MCQ one, that is PMA with the code. So question 3, so let V be a finite dimensional vector space and P is V mapping onto V be a non-zero linear transformation such that P square equal to P. So which of the following statements is not true in general? So again you have to find out this which one is not true. So for the option A we have this kernel of P intersection kernel of 1 minus P equal to this 0. So in A this P square equal to P, it is given. So if we take this P square minus P equal to 0, so P of 1 minus P, P of P minus 1, okay, so it will be, we can write it P of I minus P equal to 0, right? So let X be the element of this kernel of P intersection kernel of I minus P, okay, and P of X equal to then 0 and 1, this I minus P of X is equal to 0. So from here you can get I of X minus P of X equal to 0. So which means that X equal to this P of X equal to 0. Okay, so which is in the sense true. So this is a correct option. Let the next option is check with the option B. So B is given as I minus P whole square is equal to I minus P. So we can start with this P square equal to P given. So P minus P square equal to 0, right? So here we can write that P of I minus P equal to 0. Since, or we can do this also in this manner. So in the option B we have been given this I minus P square is given directly. Okay, so we just do this I square minus 2P plus P square, right, which can be written in the form as I minus 2P plus P. So it is nothing but I minus P, so which is indeed true. So let's check with the option C. So kernel of P is equal to 1 minus I minus P of V, this dimensional vector space, finite vector space. So we have this P square equal to P, so we can write P minus P square equal to 0, or it can be written as P of I minus P equal to 0. Okay, so from here we can write this, that I of minus P of V, it is the kernel function P. Okay, now let X be an element of this kernel of P. Okay, and we have Px equal to 0, then X equal to will be I of X minus P of X. So here we can write that I of minus P, take the X out of it. So this X is an element of this I minus P of V. From here we can write this kernel of this P is equal to I of minus P of the finite dimensional vector. So which is a also a correct option. So our last option is dimension of the kernel of P we have to find equal to this dimension of the PV, P of V. So take V equal to this real space R2. So we know that P equal to Y. So then P square equal to will be I square, which is equal to nothing but I. Again, I is equal to P. So the kernel of P is equal to 0. But we have this P of V in the real space R2. So from here we can find the dimension. That is, the dimension of P in this case will be kernel of P is equal to 0, and dimension of P of V is equal to 2. So which is not equal to this is not equal. So in our case the option D is the incorrect one. So this, which of the following statements is not true? So the option 3D is not true. So this will be the, you have to take this answer 3D. Okay. So question number 4, let W denote the vector space over R, the real space consisting of all polynomials of degree less than or equal to 6 with the real coefficients, and let D be W is be a linear transformation defined by the dp of this is given that d of p is equal to dp dx. Okay, so which of the following statements is correct? So we know that this W is P, this is a polynomial of degree, polynomial of degree less than equal to 6 with coefficients in the real space. Okay, right, and we have been given this dp of d of p is equal to dp dx. So if we put this dp dx equal to 0, then p is a constant, right? After integration we will find this p will be a constant. Then the kernel of this p, kernel of, then so d of p is a constant, then kernel of d will be a constant polynomial. Okay, and the dimension of kernel d will be 1. By the rank mutuality theorem we know, so just write this, by the rank nullity theorem we know that to find the rank of D we have to find the dimension of the W minus dimension of the kernel of D. So dimension of W is 7 and the kernel of D, we have find the dimension of kernel D is 1. So the correct answer is 6. So we have rank of D, the option B is the correct option. Rank of B, this rank of D is equal to 6. This will be the correct option.